In example A, we just had to find a common numeral and pull that common numeral out. In examples B here, parts A and B, we're going to find a common variable and pull it out. Now, sometimes you'll have a common variable and a common number, that there'll be, say, a 2 or a 3 that's common to everything and some level of variables. And sometimes it'll just be one or the other. For these two, it's just the variable. Now, the important thing to remember here is what the powers represent. Here we have a times a times a. Here we have -3 times a times a. And here we have 4 times a. So what's common to all three of these is a single a to the first power. If we pull that out here, we'll get a squared, and then we'll have -3a, and then plus 4. And if we were to distribute that back out, of course, we'd be right back where we started, since distribution is the undoing of factoring. In our second example, B, we have 12, 5, and 7, no numbers that are common, but we have an a squared, and a cubed, of course, is a squared times a, and a to the fourth would be a squared times a squared. So we can actually pull out an a squared here, giving us for our first term 12a squared. Our second term would be -5a, and then our third term would just be plus 7. And that's it. In factoring example 3 here, or example C here, we have three terms that have not only numerals that are common, but also variables. The two of them have both, and one of them has just the variables that are common. So in order to factor these, we need to find everything that's common to the terms in the example and pull it out. So our first one, example A, we have 3ax plus 9a. Now here we can see that both terms factor by 3, so we'll pull out that 3 right away. But then both terms also have an a in them, a to the first power. So we could pull it out also, get 3a outside, and then we can cancel that part from this first one and leave just x, and then we'll have just 3 for the second term. And we could see if we were to distribute this back out, we'd be right back where we started. For example B, we have x cubed y plus xy. Now both of these have an x and a y in them. So if we pull out that xy, we'll get x squared in our first term, and then we already have the y, so we don't need anything else. And in our second term, we're taking out the whole xy. Well, if we were to divide xy by xy, we'd get 1. So that's what we leave inside. And you can see if we were to distribute this back out, we'd be right back where we started. And then example C, we have 5x cubed y minus 15x squared y squared plus 25x y cubed. Here we have a 5 and an x and a y that are all common. So we'll pull out that 5xy and see what's left in each one of these terms. Well, here we have the 5 already, we have one x already, and we have the y already. So this just leaves an x to the second. The second one we have a 3. We pulled out an x, so we have an x to the first and a y to the first. So we'll have -3xy. And for the last term, we have 25 divided by 5 is 5. We already have that x, and we have one y already, so we just need y squared. So that last term is 5y squared.